Assalamualaikum warahmatullahi wabarakatuh. My name is Naramzah binti Awang. Today I would like to talk about steam turbine. This is a steam turbine is a device that which fluid expand. During the expansion work, it will be done by a fluid to the drive. An example for the steam turbine is electric generation. Okay, from the electric generations, the output will be the power. The power will be the output. Okay, we go for the steam turbine. Steam turbine is one of the oldest prime mover technologies in general production. Mechanically driven device that extract thermal energy from a multi-stage expansion of steam and convert it into a rotary motion. Okay, because of that, turbine generates commonly coupled with an electrical generator to create a power more efficient and less expensive. The steam turbine replaces its predecessor, the reciprocating steam engine. Okay, for the basic operations, it operates by means of the thermodynamic rotation cycle. Heat source by a boiler steam generator to convert the water into the high pressure of steam. Okay, we go for the steam run. Steam will be run through the turbine, convert its high thermal energy into the kinetic energy that rotates the turbine blade. Okay, pressurized steam expand through the turbine and exhausted into the condenser. Some cases intermediate temperature steam distribution system exists which deliver remaining high temperature by steam to the industrial or commercial utility. And for the last one, the condenser returns to the feed water pump and back to the boiler to continue the cycle of the rotation. Thank you.
Hello, my name is Tasnim. Now I want to explain how the turbine blades work. The steam turbine consists of both stationary and moving set of blades called respectively nozzle and rotor blades. The two sets of blades function together to cause the steam to turn the shaft of the turbine connected to the mechanical load. The stationary blade accelerates the steam to high velocity, expanding it to lower pressure. The rotating blade fitted into a wheel at an angle appropriate for the application change the direction of the steam flow, which in turn pushes against the blade, creating torque and turning the shaft. Next, turbine blade manufacturing. The steam turbine blades are manufactured from a large ingot or bar store. Each blade is made individually and then attached to the turbine rotor. Steam turbine blades are manufactured in this manner because when the blades are inspected them during outage and a single blade has enough cracking or erosion pitting that it may fail, the individual blade can be replaced instead of entire turbine. The type of metal that is used to make the blade depend on the type of turbine. The metal used for the blade of a high pressure turbine must be able to withstand the high temperature and pressure that is operated indoors. On the other hand, low pressure turbine must be constructed with material that have an increased resistance to corrosion. This is because the lower pressure in the low pressure turbine allow to the steam to condense more. This causes the steam to have a high moisture content in the form of small water droplet. At high velocity, the water droplet can be damage the blade. The piece of metal used to make the blade is prepared using a process in which heat treat the metal multiple time before it is subjected to chemical and alloying treatment in order to achieve the proper metallurgical properties for the blade. After the blade has been treated, it is placed on a computer programmed milling machine. The milling machine uses a variety of rotary tools to machine the turbine blade with precious.
Assalamualaikum and hi, my name is Raja Muhammad Fikri Shazwan bin Raja Mahdi. Now I will discuss about two topic, turbine problem and turbine startup. Turbine problem. Turbine are subjected for pitting, corrosion, fatigue, stress concentration, deposition build-up and erosion from water, droplet and solid particle. As a result, this will cause the turbine can lose as much as 50% of the total generating capacity. As I said before, because of the erosion and maybe build up of the deposition at the blade. Deposition at the nozzle also can be occur, which can alter the energy and aerodynamic flow of the steam. As the steam expands through the turbine, the solubility in the steam decrease. The contaminant, including chloride, sulfide, and sulfide condense onto the blade surface, where they concentrate at much higher level than in the flowing steam. The concentrated contaminant exacerbate corrosion, putting destroy the rotor and this in particular. So how to control it? We must make sure that content of feed water must be carefully monitored. Appropriate chemical balance in the water is maintained, so the steam turbine will run more efficiency and less cost service. For the turbine startup, we know that turbine operate at higher pressure level. So the material that we need to build up the turbine must be thick, heavy duty construction, and also have thermal. Also, the material have a high thermal inertia. For the turbine, when handle it, steam must have proper superheat to avoid it condense and damage the blade. But if the too much superheat also can cause the temperature difference between the steam and the turbine. So there's a big temperature difference between it and damage the steel or the material. In the turbine, bypass valve are used to divert the steam and to heat it up or slow down the flow of the fluid. The power of the steam turbine are produced at a cogeneration plant, and after that the steam that exit at higher temperature. This energy will be released to the surrounding as waste heat. So that's all from me.